Welcome to another Aurora Generators Deep Dive.
Great to be here.
Today, we're tackling a really important question, especially if you're thinking about reliable backup power.
Mm-hmm.
Why choose a diesel generator,
Right.
over natural gas or propane or even gasoline?
Right. It's a common question. And our goal today, I think, is to really unpack why diesel often gets that reputation.
The gold standard, some call it.
Exactly. For standby power, anyway. We want to explore the core engineering reasons, the operational advantages, why they tend to last longer.
And maybe cost less to maintain, at least in these emergency backup situations.
That's definitely part of it. And also deliver, superior performance when the grid actually goes down.
Okay.
We've looked at quite a bit of info manual specs on how these engines are built and run. Hopefully it helps you understand why diesel might be the right choice for your needs, especially with Aurora generators.
Okay, sounds good. So let's start with that first point, longevity.
Yeah.
Why do diesel engines seem to just keep going? What's the secret sauce there?
Well, a big part of it, maybe the biggest, is just how they're built, fundamentally.
Okay.
Diesel engines are typically designed with much heavier duty components. They have to be.
Why is that?
It's because they handle significantly higher compression ratios.
Yeah.
Think about squeezing the air inside the cylinder before fuel is injected.
Right.
Diesels squeeze it much more tightly than gasoline engines. We saw some examples like a Perkins engine with a compression ratio of 23.5 to 1. That's huge.
Wow, okay.
And that upstream pressure means you need much stronger pistons, connecting rods, crankshafts. The whole internal structure has to be tougher.
So they're just built heavier, more robust from the ground up.
Precisely. They're inherently tougher, built for the stress.
Like a heavyweight boxer versus a middleweight, maybe?
Yeah.
Built to take more punishment.
That's actually a pretty good analogy, yeah.
So what else helps them go the distance?
Well, another really interesting thing is the fuel itself. Diesel fuel.
How so?
It actually has some lubricating properties. It's
Right. Well, it's oily, right?
That inherent oiliness helps reduce friction and wear, particularly in the fuel injection pump and injectors, which are very precise components.
Huh. Didn't know that.
Yeah, there are even specs for it. The fuel needs a certain thickness. They call it kinematic viscosity. It should be above, I think, 1.4 centistokes to properly protect that pump.
And gasoline or propane don't do that.
Nope. They're much drier fuels, so to speak. They don't offer that built-in lubrication for the fuel system parts. So it's like the diesel engine is constantly getting a little bit of internal lubrication just from its fuel.
That's quite clever, actually. The fuel itself is part of the durability equation.
It really is.
What about heat? Do they run cooler or hotter? Does that play a role in how long they last?
It can, yeah. It's not always a universal rule, but some diesel engine designs and just the way they operate can lead to lower overall operating temperatures compared to maybe a similar sized gasoline engine running flat out.
And less heat generally means less stress.
Less thermal stress on components over time, exactly. But managing the heat they do produce is still absolutely vital. That's why you see very robust cooling systems in diesels.
Right.
Things like coolant level sensors, sometimes even fuel coolers to keep the fuel temp stable. It's all engineered very carefully.
Okay.
Oh, and even how they're mounted. The mounting systems are often designed to be really sturdy, to minimize vibration getting into the engine and chassis. Less shaking also helps parts last longer.
Okay, so it sounds like a combination.
Yeah.
You've got tougher parts for high compression, fuel that lubricates itself, and really careful management of heat and vibration.
That's a good summary. Yeah.
It makes sense why they'd be known for lasting a long time.
Oh.
Okay, let's shift gears then. What about maintenance costs? Especially for someone who just needs this generator sitting there ready for an emergency. Why might diesel be easier on the wallet in that specific standby scenario?
Well, for standby use, one of the immediate advantages is a kind of mechanical simplicity, at least compared to gasoline.
How so?
Your basic diesel engine doesn't have spark plugs.
Right.
It doesn't have a complex ignition system with coils and distributors like a typical gasoline engine.
Ah.
So right off the bat, you eliminate those common maintenance items. Fewer things that can wear out or fail and need replacing.
Yeah. No changing spark plugs every so often. That's definitely a regular task with gas engines.
Exactly. It simplifies things quite a bit.
Okay. What about service intervals? Oil changes, filters, that kind of thing?
You still absolutely need to do regular maintenance, of course. Oil and filter changes are critical.
Sure.
But Because of that robust design we talked about, and maybe the fuel characteristics, you can sometimes find longer recommended service intervals, especially in these low-usage standby applications.
So if it's just sitting there most of the time.
Right. It might not need service quite as frequently as an engine running constantly. And there are even ways to optimize this, like using oil analysis.
Oil analysis.
Yeah, you take a small sample of the engine oil and send it to a lab. They analyze its condition, check for wear metals, contaminants, that sort of thing.
Ah, okay.
It can help you determine the best time for an oil change, maybe extend it safely, or even catch potential problems before they become serious.
That's pretty advanced, so potentially less frequent routine maintenance for a standby unit. That sounds appealing.
It can be, yeah.
Now, you mentioned the fuel injection system earlier. Sounds complex. Are those parts durable, or are they a maintenance headache?
They are definitely sophisticated high-precision systems, no doubt about that.
Right.
But modern diesel fuel injection systems are engineered for durability. A big part of their longevity comes back to, well, two things we already mentioned.
Okay.
First, the fuel filtration. Diesel systems usually have very fine filters, sometimes down to 4 microns, to protect those sensitive parts from any dirt or debris in the fuel.
Keeping it super clean.
Extremely clean. And second, that lubricating property of the diesel fuel itself helps protect the moving parts within the pump and injectors. It all connects.
It does. But, and this is crucial, you have to use clean, high-quality fuel and handle it properly. Fuel contamination is probably the #1 enemy of these systems.
Got it. So keep the fuel clean, and the system is designed to last.
That's the idea. Even tiny bits of water or dirt can cause major problems in such precise components. Draining water and sediment from the tank regularly is important too.
Makes sense. We also touched on the cooling system for engine life. Does its robustness also affect maintenance costs?
Oh, absolutely, because diesel engines generally have such well-designed and often oversized cooling systems, they tend to be less prone to overheating.
And overheating leads to big repair bill.
Exactly. Warped heads, blown gaskets, serious, expensive problems. So a robust cooling system helps avoid that. Using the correct type of coolant is also really important.
Right.
Like Perkins recommends their extended life inhibitor coolant. And you definitely don't want to mix different types of coolant that can cause trouble. Proper coolant maintenance is key for long-term health and avoiding costly issues. Okay, so summing up the maintenance side for standby use. Fewer ignition parts to replace, maybe longer service intervals, durable fuel systems if you keep the fuel clean, and robust cooling reducing the risk of expensive failures.
That covers the main points, yeah. It points towards potentially lower lifetime maintenance costs in this kind of application.
All right, so they're built tough, potentially easier to maintain for standby. Now, the critical moment, the power actually goes out. Why do diesels often perform better? What makes them shine then?
I'd say the #1 performance advantage, especially for starting up a generator, is torque.
Torque, the twisting force, right?
Exactly. Diesel engines inherently produce a lot more torque, especially at lower engine speeds, compared to gasoline engines of similar power output.
And why is that so important for a generator?
Because when that generator needs to start and immediately take on the electrical load of your house or business, it needs that strong twisting force, that muscle, to get the generator spinning quickly and handle that initial demand without bogging down or stalling. It's about responsiveness under load. Although, ideally, you don't want to start it under full load, but it needs to handle load quickly.
So they have that instant grunt, that oomph, to get things going and keep them stable.
That's a good way to put it, yes.
Okay. What about fuel usage when they're running, actually powering things?
Well, generally speaking, diesel engines tend to be more fuel efficient than gasoline or propane engines, especially when they're operating under a significant load.
Which is exactly what a standby generator is doing during an outage.
Precisely. It's running, working hard, and in that scenario, diesel often burns less fuel to produce the same amount of power.
Interesting.
Plus, there's the energy density of the fuel itself. Diesel fuel just packs more energy, more BTUs, into each gallon or liter compared to gasoline or propane.
So what does that mean practically?
It means you can often get longer run times from the same size fuel tank with a diesel generator.
Ah, longer operation without needing to refuel. That could be a huge advantage in a prolonged outage.
Absolutely. Less worry about sourcing fuel and refueling in potentially difficult conditions.
Okay, that's a big plus. What about just raw reliability, dependability when you absolutely need it to work?
Well, that robust construction we started with plays a huge role here.
Back to the build quality.
Right. heavy-duty parts designed for stress. And combine that with the simpler ignition system, no spark plugs, no complex electronics just for ignition.
Fewer failure points.
Potentially fewer critical failure points compared to a gasoline ignition system. It contributes to that reputation for just working. They're built for work, for dependability and critical situations.
Makes sense. What about starting in the cold?
Mhm.
That can be an issue for backup power sometimes.
That's a very important consideration, yes. Diesel engines often come equipped with starting aids, specifically for cold weather. The most common are glow plugs.
Glow plugs.
Yeah, there's small heating elements inside each cylinder. Before you start the engine in the cold, they heat up the combustion chamber to help the diesel fuel ignite easily when it's injected.
Ah, like a
Oh,
little preheater.
exactly.
Well,
Helps ensure reliable starting even when the temperature drops well below freezing. There are other cold weather strategies too, but glow plugs are key.
so they're built tough. They sip fuel efficiently when working hard. They have that torque. And they're designed to start reliably, even when it's freezing out.
That paints a pretty good picture of why they excel in standby roles, yeah.
And handling the load itself, powering lots of stuff at once.
They're very well suited for that. Diesel generators are often the choice for handling large electrical loads, backing up entire homes, businesses, critical facilities.
Because of the torque again?
Largely because of the torque characteristics, yes. It allows them to handle those sudden demands like when a large air conditioner or pump kicks on more effectively without voltage dips or struggling.
Okay, this has been incredibly insightful. A really clear breakdown of why diesel often comes out on top for standby power. Before we sort of wrap this up, are there any other important considerations someone looking at an Aurora generator's diesel unit should just keep in the back of their mind?
Yeah, just a couple of practical points. First, fuel storage. Diesel fuel can degrade over time, and it can get contaminated with water or microbes if it sits for too long, especially biodiesel blends.
So you need to manage the fuel if it's sitting for months.
Right. Proper storage practices, maybe fuel stabilizers or periodic testing, are important for long-term standby readiness. Keep that fuel fresh and clean.
Okay, good point.
Yay.
Anything else?
Emissions. Modern diesel engines, especially for generators, will have emission control systems, sometimes called after-treatment systems, to meet environmental regulations. It's just something to be aware of. It's part of the package.
Right, clean air standards.
Exactly. And finally, the initial cost. We've talked about potential long-term savings on maintenance and fuel, but it's true that the upfront purchase price of a diesel generator might be higher than a comparable gasoline or propane unit.
Because of that heavier duty construction we discussed.
That's the main reason, yes. More robust materials, stronger components, it just costs more to build that kind of engine.
Okay, that's fair to mention. An initial investment for long-term gain, potentially.
That's often how people look at it.
All right, let's try and bring this all together then, especially for you, our listener, as you might be considering an Aurora generator's diesel unit. We've really walked through how the fundamental engineering, the way diesels are built,
The robust design.
right, and the characteristics of the fuel itself, the lubricity,
Mm-hmm.
and just a clear focus on durability throughout the design, how all that adds up to potentially longer lifespans, maybe lower maintenance needs in these standby scenarios, and really superior performance when you need that power.
Yeah, and I think this is the really crucial point. When the power actually goes out, that proven reliability, that strong, consistent power delivery you get from a diesel, that can be the absolute difference maker.
Between staying operational and being left in the dark.
Exactly. These advantages we've discussed, they aren't just theoretical specs on paper. They translate directly into, well, peace of mind and tangible benefits for you when you're facing an outage.
So looking at a diesel-powered generator from Aurora generators, it's often framed as an investment, isn't it? An investment in long-term reliability, in performance for your critical power needs.
I think that's fair. While that initial cost is a factor, definitely the potential for a longer service life, that dependable operation year after year, it offers significant value and, as you said, peace of mind.
Which really leads to a final thought, maybe a question for you to mull over.
Mm-hmm.
What's the real cost of being without power? Whether it's your home, your business,
Right.
what's the cost of that downtime? And then how much value do you place on having reliable, long-lasting backup power ready to go when you need it most?
That's the core question, isn't it? We definitely encourage you to explore the Aurora generator's range of diesel units. Look at the specs and think about how these inherent advantages we've talked about, the longevity, the torque, the efficiency under load, how they align with what you need for your specific situation.